So today we will start a new section, new topic. It is section 7.3, which is trigonometric. Again, we have trigonometric function, sine, cosine, secant, tan, and so on. And it's called substitution. Let's see what do we mean by trigonometric substitution and how can we solve the question. Let's start with question 1, and I will try to explain in question 1 what do we mean by trigonometric substitution. Question 1 is evaluate, and we're still doing integration, something like this. X squared, square root of 9 minus x squared dx. And let me start here by noting what we are doing. I want you to look at this one, this, and I want you to focus on this one, 9 minus x squared. Let me go to a special space here and give it an extra look here. Now, this is of the 4, it is kind of, we have a number, and then I have a minus, and then I have my variable, which is, I would say, x squared. So in general, it is a number minus x squared. Okay, this is the 4, some expression of this form. Whenever we see something like this, especially if it is inside the square root, if it's inside the square root, you have a number minus something which is variable x squared, and then there is a minus between them. The substitution that we will use, it's a standard substitution. I will remove x and I will take the square root of this number. If this number is 9, I will take the square root of 9, it will become 3. And then I will use the substitution sine theta. That's how we start solving questions like this. So whenever we see a square root, and then not necessarily a square root, whenever we see a number minus x squared, we use the substitution. Take the square root of the number, and then you write sine theta. Later, we will see if we have a number plus x squared, this will be something else. And then we will see if we have x squared minus a number, this will be something else. Now, let's keep us in this question. So here, I think we agreed that we will use the substitution x equal square root of 9 sine theta, which means x equal 3 sine theta. Is that clear? Why did I choose 3 sine theta? Okay. Muhammad said it's yes. Okay, now what do I need else? I know what is x, so I will take this x and I will write 3 sine theta. I will take this x out and I will write 3 sine theta. Now I need to do what? To find also dx because I need it. And if you have x, then dx is the differential, which is 3. Can you remind me what is the derivative of sine theta? Turn on the mic and please say it. What's the derivative of sine theta?
Cosine.
Cosine. So we have cosine theta, d theta. Now we take those information, and I think it's time for us to substitute them here. So what do we have? We have integral of x squared, square root of 9 minus x squared dx equal to I have to take every x and I write something else instead of x. So the first x, I will just write 3 sine x. So here 3 sine theta. The other x, I will remove it and I will write 3 sine theta. And finally, you have this dx, you have to write 3 cosine theta d theta. And now we will start doing the simplification. Let's see, what are we going to get here? First of all, 3 sine theta squared, this will become 9 sine theta squared. You have also 3 cosine, so this would be also 3 cosine theta. And here you have d theta. That's what we have at the beginning. Now we have the square root of 9 minus 9 sine square theta. So far, so good. That's what we get. Let's see if we can simplify this a little bit more. Nine with 3 would give me 27 sine square theta cosine theta, because I cannot change it, d theta. Now, take 9 as common factor. What do we get? We get 1 minus sine square theta. But if you remember how much is this one? 1 minus sine square theta. Can you remind me what is 1 minus sine theta squared?
Cosine square theta.
Exactly. So this is cosine square theta. And all what we need to do is we just write what is it. So this would be 27 sine square theta cosine theta d theta. And here is 9 cosine square theta. That's what we get. Now, if you take the square root of the denominator, that would give me 27 sine square theta cosine theta. It will give me, I think it is 3 cosine theta. And now it's the good news, because now it's the cancellation. So I would cancel cosine with cosine. And 27 with 3, I would just get 9. And then I can go outside. So we are going to get this one. 9 integral of sine square theta d theta. So far, do you have any question? Because now I change my original integral, which was complicated one, into a very simple integral of sine squared. And this is why we call it trigonometric substitution. I substitute the x into sine, and then the integral will become very easy and simple. So please, do you have any question before we continue? Because we didn't finish. Well, I think there is a question by Nu'man. He is wondering, how did we get sine at the first place in the expression? So Nu'man, if you remember, we said if we have a number minus x squared or a number minus anything squared, the standard procedure, because of this minus, is to use sine theta. This is kind of a standard procedure. Whenever you spot in the integral, especially inside a square root, if you spot a number minus x squared, you will use this procedure. Is that answering your question, Nu'man? Okay. Do you have any other question before we find the integral of sine squared?
دكتور عندي سؤال.
تفضل.
بالنسبة للتعويضة لازم نحفظها ولا نقدر نستنتجها؟
قصدك شلون سوينا substitution اللي هو هني؟
لا يعني يعني أحفظها بس من أشوف 9 رقم ناقص إكس سكوير بس أعوض ما أقدر أستنتجها.
يعني تقدر تفكر ليش احنا سوينا كذي؟ بسبب هاي اللي هني بيطلع. تشوف الشاشة صح؟
ايه أشوفها.
ايه هاي السبب. ليش اخترنا الساين؟ لأن لما ناخذ بعدين 9 اوتسايد بيطلع لي 1 ماينس ساين سكوير أقدر أوديه إلى كوساين. يعني الفكرة إن هاي اللي تحت داخل السكوير روت بشوية صاغرة ما بكذي شيء ناقص شيء. عشان كذي سويته كوساين سكوير وطلعته من السكوير روت.
اوكي تمام.
Now, can you remind me how we do sine square, the integral of sine square? It is, we did it before. If you can just quickly remind me, what is the, or how do we do the integral of sine square?
Substitution.
نفرض يو
No. It is, you remember we used the double angle formula, which is 1/2, and then it is 1 minus cosine 2 theta d theta. Do you remember this double angle formula? We said whenever we see the sine square. Now, if you do this integral, you take the 2 outside. And then what's the integral of 1? Integral of 1.
Theta?
Theta.
Exactly, it is theta. And usually the student did this famous mistake of writing it as x. It is not x. Remember, everything now is theta. So this should be theta. This is theta. Minus integral of cosine is sine 2 theta. And because of this 2, I have to divide by 2 plus c. One final step that we need to do is this one, theta minus half. Now, do you remember the formula for sine 2 theta? Let me do it here. There is the double angle formula. Yes, exactly. It is 2 sine theta cosine theta. You will see why I need this in a minute, but bear with me now. So this is 2 sine theta cosine theta. And the final answer would be 9/2 theta minus sine theta cosine theta plus c. Do you have any questions so far? Finishing the integral, it's a long process, but it's worth it. But do you have any question? Do you have a question? Hello?
No.
Okay, now are we finished? Are we done? We find the integral, we find the answer. Yes or no? What do you think? Are we finished here?
Yes, I think we can.
Well, it is not. Yeah, it's almost yes. But you remember we started with x, so the final answer we should return it back to what?
X.
To x. Exactly. So let me go to the next page and let's continue. For the next page, I'll just remind you of my final answer, which is, let me write it here. It was 9/2 theta. Was it a negative? Sine theta, cosine theta. Now I need to find how much theta in terms of x, how much sine theta in terms of x, and how much cosine theta in terms of x. So I have to remind myself what was the relation between my x and theta. X equal 3 sine theta. Is that correct?
Yes.
Okay. Now I want only sine theta. Remember, we need to find the sine theta. How much sine theta alone? Let me do it here.
x/3.
So one of the mysteries here, the final answer will be x/3. Okay, we find one thing. Now, from this equation, sine theta equal x/3. How can you get theta alone? Remember, I need theta here. How can I get theta?
Shift sign.
Sine inverse.
Sine inverse, exactly. So from here, I would say theta as alone, it will be sine inverse x/3. Now, why is this? Oh, how can I get this? You can just do here very simple by taking sine inverse of both sides. So if you put sine inverse and sine inverse on both sides, here is sine theta and here is x/3. Now you know that sine and cosine, sine inverse and sine will go away. You will just get theta, which is this one. So we find the second piece of information that we need for now. So this is just sine inverse x/3. Now the final piece of information is to find the cosine. We find the sine, we find the theta. Finally, we need to find the cosine. How I'm going to find the cosine, please here focus with me because this is very important and to be repeated throughout this session here. Now, remember if we have a right rectangle here with angle theta. Okay. Do you remember what was the sine of theta? What over what? With respect to the triangle. What was sine theta?
المقابل على
مقابل الوجه.
المقابل, which we call it the opposite, over الوتر اللي هو hypotenuse. So it is this one, which is the opposite, over this one, which is the hypo. Of course, if you wonder what is this is usually we call it the adjacent. So we have opposite, adjacent, and hypotenuse. Now, if you look closely at this equation, can you compare how much is the opposite and how much is the hypotenuse?
opposite is x, so
Is x. And hypotenuse is?
Hypotenuse is 3.
So what do you think the adjacent is? It's the remaining one. So we go back here, and this is x, and this is 3. Now I need to find how much is the adjacent. Why do I need the adjacent? Because the cosine is what? The cosine is the adjacent over the hypotenuse. So let's go back here and let's find the adjacent. How do we find the adjacent? Any suggestions? Any ideas? How can we find the adjacent? Pythagorean's theorem. What is the Pythagorean's theorem? Usually in this case, it is the adjacent square plus the opposite square equal the hypotenuse square. Now the adjacent, which is something I don't know. How much is the opposite?
X.
So this is x squared. How much the hypotenuse square?
9.
9. Now we take x to the other side. It would be 9 minus x squared. So if you want only the adjacent, you will get this one. Big square root of 9 minus x squared. And that's how you find the adjacent. And all what you need to do next is to write it down up here as a final answer. Square root of 9 minus x squared over 3. Do you have any questions, students?
No.
Okay. I know how long this question is. It's a very lengthy question, and it's a typical exam question, and it takes time. But believe me, all the problems in this section will go exactly in the same way. So everything will follow the same procedure. You will find the trigonometric substitution. Sometimes we'll use sine. If it's a plus, we'll use tan. If it's the opposite, we'll use secant. You do the substitution. You find the integrals in terms of theta. And then you will go back here and you will change theta into x back. And usually you have to do this Pythagorean opposite and adjacent idea. So this question will be repeated with us. If you practice it at home, it will repeat it with you at home. So there is no worries about it. Just try to practice and practice and practice. Okay, do you have any question